Hi, my name is Michael Young. Thank you for your time, and I'd like to show you my framing hammer invention. This is the framing hammer. Obviously this is made out of plastic, 3D prints with some metal parts, but it would be ultimately intended to be cast titanium with a wooden handle. This is a 25-ounce framing hammer. Very typical in size and striking surface to any hammer you could find at Home Depot or Lowe's. So the benefit of my invention is that it accepts a set of collated framing nails. This is 30-degree paper taped, full round head, and it can be included with the hammer and then automatically dispensed with one hand into wood. Because this is a plastic prototype, I'm going to be driving into insulation foam today, but it should be able to illustrate the function. So there is a single button on the side here. Also there's a safety, so I can engage or disengage the safety. But this button here will be used to load the nails and actually set the nails. So I can open it up, load the nails in, push them in with my finger, and then the hammer is loaded. It has a set of nails inside. I can accept any number of nails, full clip, half a clip, 3 nails. So once it's inside, I'm going to be striking this like any normal hammer. You can still tear down a wall with this thing. If I engage the safety, nothing is going to happen at all. I can literally tear down a wall, use it as a normal hammer, claw anything. But as soon as the safety is disengaged, this activation button, I can use it to strike the hammer on the side of the head. You can see it's set, and the nails are now advanced 1. So once it's set, I can literally just drive this into the wood, and there is a nail placed into the wood. So I can use the hammer to drive it in the rest of the way. I'm going to hit too hard because it's plastic, but there's one nail, and then next nail I'm just going to do it again, set it, drive it in, hammer it the rest of the way. So potentially a much faster method for hand driving nails. So that's what it does, but why is it so great? First of all, this is a vast improvement on the efficiency and ease of driving and setting nails by hand with a hammer. Second of all, this is now an entirely one-handed operation. Typically, users have to use the second hand to set nails into the surface of the hammer or into the work surface. Now, the second hand is entirely freed up to fix boards in place, hold them, move them, while driving and setting multiple nails at a time. Third of all, this device is actually specifically aimed at enhancing and streamlining the relationship between nail guns and framing hammers on the worksite. Currently, there are 2 different types of nails required on the worksite. Singles for your hammer, and collated sets for the nail gun. Through my research, I found that framers, instead of dealing with the annoyance of having to buy both types, carry both types in their tool belt, and then pull the right kind out at the right time, will instead opt to only buy collated sets. When they need a single for use with a hammer, they will physically break these one by one off the set and then use them with the hammer. It's inefficient, time-consuming, and actually can be painful after a long time. This device totally streamlines that process by allowing you to only buy one type of nail, collated sets, and then it can efficiently dispense those faster than you can a group of singles. Through the rest of this video, I'll actually go into more depth about all these benefits, as well as talk about the research I've done, and then do a product breakdown where I take this apart and show you exactly how it works. I'd like to talk a minute about some of the research I've done in the framing and construction industry, and some of the problems and opportunity areas that I think have been highlighted that would point to this being a viable product for the market. A lot of my research has been talking to framers, guys that have been in the industry for a while. Some of the best research has been with guys that have been in 20 plus years, have multiple teams of framers. They were extremely helpful, answering all my questions, really talking me through stuff they care about. To get to the basics, a framer will use 2 essential tools. They have the nail gun, and then they also have the framing hammer. Obviously the nail gun is a more recent invention. It's massively more efficient at driving nails than the framing hammer. So that is the main tool that people use a large percentage of the time. Obviously it's using these collated sets that are pre-organized, all lined up, and then it's super powerful, bam, 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 just putting them in. There are limitations to the nail gun though, which, and then it also doesn't actually replace every feature and function of the hammer. So every framer out there still keeps their hammer. They have a loop for it on their belt. It sits there while they work, but then there are some key situations where they really do need the hammer, so they have both tools. Some of those situations include when the nail gun is actually limited. Obviously, your battery can run out. Your compressor can die. It can be inconvenient to actually set up a nail gun for like a short task if you're just punching a bunch of nails, tearing down a wall inside someone's home, not a long project. Also, there's places like a nail gun can't reach, so if you're holding it up in the air and trying to reach into a tight spot, there's boards close together and you can't actually finagle it in there. They're obviously large objects. The framer will want to pull out their hammer for those certain situations where it's just a superior and more slender object. Also, there are some benefits to the hammer which the nail gun does not replace. It has a claw in the back for removing nails. It's just a heavy object on a stick which you can use to demolish things. You can use it as a pry bar to pull boards apart. You can tap boards into place. You can claw boards into place. Essentially, it's just a really useful tool for a lot of things that the nail gun does not do. So you want it for all those things, and then you want it for driving nails, and there are certain situations where the nail gun just doesn't cut it. So, that being said, both devices are essential on the worksite and necessary, but there are actually some inherent problems in their relationship. Through talking to framers and watching them, I found that one of the biggest problems is that they both require different types of nails. So the hammer obviously is requiring a single nail, and the nail gun is requiring a whole set. This creates a number of efficiency problems, and there's a number of ways that the framers actually get around it. You can just buy a whole box of singles. You can keep those on you. You have to get a whole handful of them, put them in your tool belt, and carry them in addition to the collated sets, which is actually annoying for framers because they're more often using the collated sets and very seldom using the singles, but they still have to buy them and keep track of them and keep them in their belt. So actually, the more typical solution is that framers will only carry the collated sets. They won't even buy the singles. They'll only carry these in their tool belt. It's more efficient that way. But then when they need them, they will actually physically break one nail at a time off the set and use that with the hammer. So this, on the work site, is actually less efficient because you're taking the time to break them off. If you had a bunch of singles, it would be more efficient, but you don't actually have to buy a bunch of singles, so it's preferred. So that's where this device comes in. It's integrating the relationship between the two, allowing you to only buy one type of nails, the type of nail that people are already using more often than not. And it's actually very efficient to use this on the worksite and dispense these nails with the hammer. To talk more about some of the findings in my research, when I was actually able to bring up this idea with framers and talk through some of the thoughts they had with it, one of the key things that came out of that is that they would really like an additional feature added to the hammer. They thought that was great, but they really don't want the essential qualities of the hammer to be detracted from. They don't want it to get any worse. They don't want to give up any of its features. So actually, I've been developing this for 6+ years. This is the 9th complete functional variation I've tried. And some of the earlier prototypes had a magazine off the back that came back here with like a spring-loaded advancement method, just like a nail gun that pushed the nails forward into the head. But the disadvantage of that is that you have this huge extrusion coming off the back that inhibits you from being able to put it into a loop on a tool belt. It's one more breakable object on the hammer. If it's made out of plastic, you can just accidentally crack that thing off. It messes up the balance. One more reason why you'd want to make it out of plastic. There's like all of a sudden more weight above the head of the hammer in an awkward position that would rotate it. And it's obviously less useful for clawing in a demolition mode. You've got something in the way. So anyways, this has a unique mechanism that I developed. Actually, in the patent I filed, there's an attempt to isolate that mechanism so that it can actually be used to replace nail magazines and even a nail gun. But it's a mechanical method that uses a hook and some teeth to mechanically pull and advance those nails one by one forward towards the head. So there's nothing pushing them in. Instead, it's actually pulling them one by one forward. And it, because it's mechanical and it just has these simple steel pieces, hopefully it's more durable. and less likely to jam and stuff like that because you're actually forcefully pulling them forward. So that's one of the benefits of this. There is no magazine coming off the back. It's a very simple profile. It's shaped exactly, almost exactly, like a typical framing hammer. It fits into a tool belt, and it's just as simple. It's just as durable as a typical hammer, so it's not getting any worse. As I mentioned before, there's the safety on there, so once the safety is engaged, even if you have a whole set of nails in there, it's still going to fit on your tool belt. And you can literally tear down a wall and never worry about this thing opening up or breaking or anything like that. Like I mentioned before, this is cast titanium on the front and a wooden handle, so it's extremely durable. And then there's been a lot of attention to balance it properly too. So a lot of the weight in these frontmost portions is focused on the front head, so all the weight's above the striking surface, and then it's just a lightweight handle. Okay, so I'm going to do a quick breakdown of the hammer, take it apart for you, show you the various assemblies inside, talk a little bit about maintenance, material choice, and then also talk about the manufacturing for the different pieces. So first things first, the handle, like I already mentioned, is intended to be made out of solid wood. As you can see, there are some metal elements that extend through the front surface here, and there's a pin here that lets one of them rotate around that pin. But for the most part, it is solid wood. It's shown in two pieces here for prototyping purposes, but it would be one solid member. And the choice for wood instead of anything else, which obviously it could be plastic or rubber, something that's synthetic, overmolded over it, like a titanium core. But the choice for wood is really for like sort of a more marketing and design related purpose. There's elements of this hammer that are definitely more high-tech and complicated than a typical framing hammer, and I think maybe the problem that could cause for a typical or potential consumer is it looks like something they can't understand or something they can't interface with, a little too high-tech. It's got this slot in the surface and some additional pieces and fasteners. So whatever can be done to bring it back towards a more simple, traditional, basic, even typical appearance, I think would be very helpful. So that's the intention behind a very solid wooden handle. A majority of this device is something that somebody already knows. That's just a wooden handle, and then there are some additional features in the head. So that's the thought there. I'm going to take a second to remove these fasteners. I have some machine screws here, but just for prototyping purposes, they would ideally have a larger head on them to hold the wood in place, but they're just smaller heads for this prototype. So I'm going to take them out and then take this apart here. Okay, so the fasteners are removed. The handle slides right off the main body assembly here. So we have this wooden element. Again, you're seeing a separation there in a fastener, but that's just for the prototype. This would be a solid member of wood here. So that's the handle, and then the main body, and everything in here would ideally be cast titanium or metal. And I mentioned cast titanium for weight purposes. This is aimed at being a 25-ounce hammer, so the way that is achieved is through lightweight titanium. If it was steel, it would be a little heavier. And 25 ounces has been selected through research as an ideal weight. Obviously, when you're adding nails, it's getting a little heavier, and then when you're moving the nails, it's getting a little lighter. And 25 ounces is right there, sort of in the sweet spot, a little bit less than what a serious framer is going to be wanting to use for framing. So that's that. But this is made up of three main essential assemblies. There's a left body, there's a right body, and then there's a central piece which is connected to the head that pivots in and out between those two bodies. The left and right body, actually, with this fastener here, capture that internal assembly, the center assembly, in the front of it, and then behind it it's completely captured and contained. And then there's these two members that extend back, and then again to that pivot point in the handle. So partially that just helps engagement with the handle for a strong connection, so that over time it doesn't twist off like something with a short connection point, but it has a longer connection point for strength. And then also there's that pivot point there. So I'm going to remove these two fasteners here to break apart these three main assemblies. And then I'm also going to be removing this clip right here, which is part of the striking surface assembly. This clip actually keeps the left and right bodies together. It helps them slide, and it also just increases longevity of the product. They could stay in place, obviously, because they're metal. They won't bend right away, but you know, after 10 years they're going to potentially be flexing. So this keeps them all together in the bottom of the product. Okay, so this clip comes right out, and then there is my left body. Here is the central assembly, and here is the right assembly. There's three main pieces, and for any reason, if you want to take this apart, these are the main three parts that you're going to be interacting with. I'm just going to put this clip back in for reference. That's part of this assembly. But basically, it's three large pieces which are not too complicated. As you can see, within these assemblies there are some smaller pieces, but there does not need to be a lot of interaction with these smaller pieces for maintenance. And you may want to take it apart just to get some leaves and mud out of it if you got whatever, something jammed in there from doing demolition. Sure, you can take it apart and just hose it out, get it clean, but ideally it doesn't need to be taken apart that often. Hopefully you can just toss it in a bucket of water to clean some mud out if you really need to. But that's that. So it's these three main assemblies. Everything in these assemblies is intended to be manufactured with titanium, like I mentioned, which obviously is it starts with the process starts with plastic injection molding. That plastic piece is then coated with a mold, and then that mold is used to cast the titanium, and then the mold is broken off and you have your titanium piece. So these all start as a plastic piece in the manufacturing process, and they're all designed to be very simply molded as plastic pieces with two-directional molding. There's one instance right here. You can see there's a notch in the front of this here that would require some action in the mold to fill that gap. But aside from that, actually, every piece in here is designed to be a two-directional mold. So that would obviously help cost with manufacturing. So for the purposes of this video, I may not need to go into a lot of detail about the various assemblies, but I'll go very briefly. This left body has a spring slider motivator in there. Is actually forcing this central piece out of the front of the hammer. So it will pivot around this rear point here, and then it's trying to leave the hammer like that. This piece is the piece that actually holds the nails. So it's got a track here. You can slide the nails into that guy, and that will take the nails with it wherever it goes. And then the right body assembly contains the nail advancement mechanism, which I talked about earlier, and this part here is the U-shaped hook, which has some internal teeth in there. You can see them on these inside edges here that actually will grip and grab the nail heads. It grabs the nail heads, so I'm going to orient here so we can see it. So it's actually, once those nail heads are captured by those teeth, it can't move forward and backwards. It can slide up and down into those teeth, but once it's in there, that U-hook has authority to move those nails back and forth. So you can see here there's some tracks on the inside surface of this hammer that the nail heads typically rest in when the hammer's all closed up, and that keeps the nails from being pulled out the back, and they don't vibrate and pull back and forth. But as the internal assembly moves them down, they are then being admitted into the inside surfaces of this U-shaped hook, like this. So now they are captured by that U-hook, and then there's some various pins in here that allow that U-hook to travel forward and pull the nails forward with it, which orients them in front of a striking surface here that will break the front nail off as the entire set of nails is moved back, is forced back into the hammer, and then travels up again up these nail tracks without the frontmost nail, which will have been broken off. On this side, you can see the activation button and the safety here. Activation button is moving this latch here, which interacts with little latches and catches on this internal assembly, and that actually is limiting the travel of that as you're moving that latch up and down there. And then the safety itself is locking out that button, so the button doesn't move when that safety is engaged. So again, in summary, all these pieces are moldable with two-directional molding, except this little piece of action here, which actually could be, it's not needed, it's not necessary, but it is beneficial. So if there really was some cost cutting that needed to happen, that could be also molded from the side with two-directional molding. And then additionally with this piece, something to point out, this can be replaced with a different piece, and the head could get a little bit longer here, and this actually the size of this track for the nails could be augmented or diminished to fit different nail heights. These are 16D nails. They're 16D sinkers, which is 90% of the time what you're going to be using for framing. 8D would be the other type for like sheathing and stuff on the outside of the house, but 16D is for 2x4s. There are variations in length for these guys. This is a sinker, so you're actually going to be a little bit shorter than like a standard 16D. There's tons of forums and stuff that talk about the proper length. This is the preferred length. It's the most typical. This is what most people are using. But if you're not using a sinker, it might be just a little bit longer. So basically this piece can be replaced and have it be maybe 0.25 inches longer to accept a different nail size. And you could either sell this piece separately, or you could sell different versions of the hammer that are tailored to even different degrees of incline on these nail sets. This, like I said, is a 30 degree, which is tailored towards battery operated nail guns, and those I feel are the trend right now. It's what things are moving towards. Obviously you don't need a compressor and a bunch of hoses. The framing teams that I've talked to currently are moving towards all 30 degrees, so this would be the most typical, but there are 21 degree, there's other different inclines, different degrees of nail sets. So if you wanted to have a different nail set, maybe you would sell a different hammer that would be specific for that degree, and then you could replace this piece for different nail lengths. So that about does it. Thank you again for your time and for watching, and I look forward to hopefully being in touch with you. Thank you.